Hello, YouTube. Welcome back. Let's see. We are doing Chapter 6, Lab 5, C5X0. This is a lab that I just added on. It's not really on the lab sheet. What we want to do is play the rock, paper, scissors game and investigate the use of if statements or conditional statements, right? Okay, so let's let's cd the YouTube folder, or directory, I should say. And here's all our stuff. We finished Lab 4. Let's see, didn't we? I guess we did. It says C4X18 down there. I don't see it over here. Isn't that odd? Oh, there it is. Okay. All right. So let's make a directory. C5X0. All right. CD, change directory to C5X0, and we're good to go. All right. So let's start with RPS tester, rock paper scissors game tester. Okay. So new file, a new editor. Okay, so let's see, multi-line comment. Whoops. So this is going to be RPS tester dot, whoops, tester. What was that? Alrighty. .java, and your name, and the date. Now, we did this last week, but today is, I think, December 2nd. There you go. And let's save that. Alrighty, so I'm going to highlight this, Control C it, and let's save it. All right, in the YouTube directory, and down to C5X10. Where is it? There it is, C5X0, right? That's it. Alrighty, and so let's select that. Select that. Select it. Okay, and then save it. All right, and I can never tell if it's done it or not. This is driving me nuts. Sorry, let's see. While we're here, oh, what happened? It didn't do it. What the heck? OMG. All right, RM untitled. Remove file. Let's start over. Okay, so new file. Header comment. Multiple lines. Okay, RPS tester.java. Why is it doing that? There's a lag on this keyboard. It's driving me crazy. Okay. All right, let's try this again. So let's save it. There you go. And where? Let's go to C5X0. Why isn't it selecting? The untitled's still there? What's going on? Okay, so if we go into C5X0 over here, well, it's not selecting. We still have untitled. What is going on? It's not there. Oh, it just updated. Well, something's laggy here. Okay, don't think about it. Okay, we're good. Alrighty. So, purpose. We were talking about doing rock, paper, scissors, lizard, Spock, like in Big Bang Theory, but that's way too many combinations. How about use conditional statements, in other words, if statements. Conditional statements. Whoops, what happened there? This keyboard is really laggy today. I don't know, something, I think it's CS50, something online here. All right, anyway, use conditional statements to play RPS game. Yay. Okay. Required files. All right, the main one, the main class. And the derived class. Let's say RPS.java. This will be the derived class. Okay, so let's see, we're going to make this the translator phase. Java C, syntax, checker, early binding, all that fun stuff. And interpreter phase. All right, this is where we got to check our semantics. What happened there? Interpreter phase. There you go. And the late binding. We'll talk about that when we get into inheritance and polymorphism. There you go. All right, now are we going to import anything? Yeah, I think we're going to import scanner. Hang on. Yeah, I know. Where is my cursor? Hello? I lost my cursor. Yeah, I know, stop that. There it is, okay. All right, so imported classes. We're going to import java.util.scanner for input. And java.util.random to let the computer make a random choice of rock, papers, or scissors. Okay. All right, so public class. Well, this is my main class, main method, main routine, whatever you want to call it. Public class RPS tester. Public static void main string array args. We're not using it for input, but there it is. All right, so the first thing we're going to do is going to construct a scanner object. Scanner, let's call it, I don't know, input equals new scanner, and we're adding functionality to the system.in class. Whoops, yeah. Okay, let's prompt the user. System.out.println. Let's prompt them to make a move. Make a move, yay. All right. Okay, so quote, make a move. There you go. All right, so then let's capture that input with, how about a string called person move? And that's going to equal input.next. What the next method does in a scanner class is it waits for you to type in a string. It could be one word, it could be a sentence, it could be a whole book. And then when you hit enter, it takes the input at that point. So it waits for you to hit enter. Alrighty, so that's the person's move. Okay. Then how about we take the random class? Let's make a random object. Random, I don't know, I'll call it gen for generator, equals new random. Okay, and what we're going to do is we're going to make an integer called computer choice. Choice, because the move I'm going to say is a string. Choice is going to be an int. So computer choice is gen.nextint. Gen.nextint. Nextint what? Well, remember, nextint 3 would give you 0, 1, and 2, and those are the choices, right? So now we have to decide. We could make 0 if that random number is a 0. Let's say the computer is selecting rock. If the random number is a 1, let's say the computer's making the move paper. And if the random choice is 2, let's say computer move is the string S for scissors, okay? So we're going to enter RPS for our moves, okay? So let me think here. All right, how are we going to do this? How about, all right, so let's create a temporary string. Let me move this down a little bit. Move this up a little bit. Alrighty. Okay, let's make a string. Let's call it computer move. And let's initialize it to the empty string. And we're going to figure out what that computer move is. So if computer choice equals 0, then computer move is rock. Let's say computer move equals rock. There you go. All right, now these are independent ifs, so I'm not going to do if, else, if, and all that kind of stuff, just 3 ifs. All right, maybe I can just copy this. All right, so if computer move is 1, let's make it paper. Alrighty, let's move this up a little bit. All right, so if computer choice, the random integer that we selected with next end, right? If that turned out to be the integer 1, let's say that represents computer choice. What happened there? Why is this doing this? My keyboard is acting crazy. There you go. So if this is a 1, and let's say the computer choice is P for paper. And if computer choice is 2, let's make the computer move scissor. Alrighty, there you go. And so here comes the class. Let's make an RPS object. RPS, I don't know, foo equals new RPS person move and computer move. So we're passing the information of what the moves are, and then we're going to let RPS decide who won. Alrighty. And so let's do that. System.out.println foo.getWinner. That method. Okay, so there's the whole tester. There might be 1 or 2 modifications, but that's basically it. Okay, so let's save it. And there you go. All right, let's make RPS, the class RPS now. All right, so RPS.java, your name, and the date. And how about we save this? All right, in the YouTube directory and in the C5X0 subdirectory. Why does it ever select? All right, did it do it? There it goes, did it, okay. Okay. Okay, so let's start with the constructor. Public, okay, public or not? Well, wait, let's write public class RPS. Okay, so constructor, public or not? Public, void or not? No, the name of the class is the name of the file, is the name of the constructor. And then we have 2 inputs, string person and string, let's say person is person move, and string computer is the computer move. Alrighty. And it's going to be a very basic constructor. All it's going to do is store that information. So how about this dot person equals person, and this dot computer equals computer. So now we know we need 2 private instance fields. Let's go up here. All right, public or not? Nope, private. Void or not? Nope, string. Person, and likewise private string computer. Alrighty, and so now let's write the accessor get winner. Okay, so what we said was we decided to make this like a toString. Okay, so we're going to say this. We're going to say public or not, public, void or not. Nope, it returns a string, one, right? Like a tie or a computer one. You know, that's going to return that kind of a string. Get winner. So we figured out in class the easy way to do this is to declare a local variable that you're going to return eventually. Let's call it temp, and it has to be a string type in this case because it's returning a string. Do some say calculation and then return string. Because we found out in class the problem was if we didn't do it that way, we'd have multiple returns inside if statements, and Java C won't allow that. Okay, so in other words, it's possible that all the if statements that we're writing, we're going to write a whole bunch of if statements here to figure out who won, right? It's possible that maybe they're all false, or maybe we messed up, whatever, you know, and it never returns anything. That's not allowed. So the easy way to do this is to declare a local variable, build up whatever you want in it, and then return that. Okay. So like, for example, how about this? What if person, now remember it's a string, right? Now I'm saying right now I'm checking for ties. When do you have a tie? When person and computer are the same move, right? When they're both R or they're both S or they're both P. But you can't do this because the person is a string object and computer is a string object. And so when you compare them with an equals, you're comparing the contents of the object, which is a hexadecimal address in RAM, and where the object is stored. That's not what you care about, right? You care about the contents of that object. You care about if it's an R or a P, right? So what we're going to do is we're going to use the .equals method, which is a method that is defined in the object class. Now, every class that you write is a subclass to the object class, so you inherit the equals method. But with the default equals method is not usually what you want. So what you want to do usually is write your own equals method for your own classes, for your own objects. So as it turns out, the string class has this done for you. So that's what you want. So if person equals computer, what are you going to do? You're going to make temp is something like it's a tie. Okay, there you go. Done. All right, so anytime that person equals computer, you get a tie. Now, I could actually run this, but you're not going to get any output unless it is a tie, right? Well, I mean, that's going to happen. So I guess I could test it this much. Let's see if this much works. Okay, so let's save it, Control S. And let's go to C5X0 and see what's going on. Okay, so we got everybody here. Yep. Okay, so Java C, RPS tester. .java, there you go. Let's see if we messed up anything. Ooh, what did I do? Variable temp might not have been initialized. I thought I initialized it. Okay, line 22 in RPS. Did I initialize it to? Oh, yes. Okay, so you have to initialize it. Like we did in main. We initialized our. Where is my cursor? I lost my cursor. There it is. Just like in the tester class, we had a string that we initialized to the empty string. So let's do that. And save that. Okay, let's go back. So Java C RPS test. Whoops, what happened there? Let's see what else we messed up. Nothing. Okay, so now let's run it. All right, so let's get rid of the .java, and let's get rid of the C in Java C. I guess we could have just typed it, so it's not going to save me a lot of typing. And there it is, make a move. Do I want make a move to go to the next line before I actually enter the room? That's weird. Okay. And it's a tie. Oh, there you go. Now, how do you know if it works? Maybe something's wrong and it's saying it's a tie when it's not a tie. I should probably have some basic accesses that returns the private instance field so you can see what they are as well. All right, let's go to the tester. let's change a couple of things. How about up here when we ask for the person's move, let's make that a print line when we prompt the user. All right, so let's make that not a print line, but a print. And maybe we'll make a little space or something here. Make a move, colon, space, something like that. Make it look better. Okay. And then down here, we're also going to print out, or we tried this in class too. Initially, we did a system out the print line foo.get person or foo.get computer before we actually constructed the object. That's sort of weird. Don't do that. So how about we do it after we construct foo, an RPS object, and we do system.out.println. Let's see. Person move is concatenate foo.get person. We got to write this accessor, but there you go. What did I do? Person. Okay. And likewise over here, system.out.println. Computer move. Wow, what was that? Computer move. What is going on? This keyboard is driving me nuts. Okay, computer. There you go. Move equals, and let's make it foo.get computer. So we can see that it really is rock, or scissors, or what it is, right? When it's the tie. So save that. Now let's go over here and write those accessors. How about we do that? How about we put that right here? Okay, so get person, public or not public. Void or not string. It's returning a string. Get person. And all it does is return person. So we can see what it is. The contents of that object, that string object. And likewise here, public string get computer, move computer, return computer. Save that. All right, let's Java see that. All right, so if I do rock, look, it's on the same line there. That's good. And see, no output because it wasn't a tie. Okay, run it again. Let's do rock. And now it is a tie because it's both R's. Perfect, that's nice. All right, let's, for fun, do it for S. Let's see if we get two S's. We didn't get two S's, so no output. No output from get winner. And how about this? There's a tie. Okay, how about for paper? Nope, no output yet from get winner. And we could put this in loop eventually. I think next chapter we're doing loops. We'll probably redo this with loops so we can play multiple moves without running it over and over and over again. And there you go. So that seems to be working. Okay, good. So let's finish this up. Now, one other little thing. What this is a standard toString method. When we talked about the equals method that is inherited from the object class, and you usually have to override it, make it your own, so that it represents your object's private instance fields, right? The same thing with the toString method. There's a toString method that lets you print out an object. Look, what if I just printed out, instead of foo.getWinner, what if I just printed out foo? Can I get down here? Where am I? Where is my cursor? There it is. What if I just printed out foo? Look what happens. That. Okay, whoops. Like that. Okay, save that. Look what happens. Now, we've done that, right? When we did, like in the second chapter thing was, we created a rectangle object, let's say rectangle Bob equals new rectangle, and then we printed print line Bob, and it printed out all the private instance fields of the rectangle, right? And that's because the toString method was overridden from the supercosmic object class, we call it, And otherwise, it does this. Look what it does. Unless you override it and make it print out, your private instance fields. Did I save it? Yes. Okay, so let's Java C that and see what happens. Wait, I did the clear. The Java C. Okay, what do we mess up now? Nothing. And boom. All right, so R, let's say. Look what it does. It prints out the name of the class, RPS at, and then 2C31AC05. That's a hexadecimal address in RAM where the object is stored. The RPS object, foo. That's not really what you want, right? Okay, so this is how you fix it. You take the getWinner class that we wrote, but make it a toString, because that's what it does. It returns a string that describes the object. That's what a toString does. So that's basically what this getWinner is. So you could keep it calling it getWinner and do foo.getWinner in the print line, but this is much more elegant. And get used to using toString methods that describe your objects. Okay, and it describes all. It should list out all the private instance fields. So, if most toStrings, what they do is they print out all the private instance fields. So that's your access or get person, get computer. But we're not doing it that way in this one. So there you go. All right, let's see what happens now. So let's say R. No output because there wasn't a tie. Okay, run it again. R. No output because it wasn't a tie. Oh, give me a tie, come on. And look, now it's a tie instead of RPS at some huge hexadecimal address in RAM. So there you go. So this is really a toString method we're writing. So we're using if statements. We're doing a toString method. It's very interesting. Okay, now, what else can we do? Well, we have what? There's 3 different ways to tie. There's 3 different ways for the computer to win, and there's 3 different ways for the person to win, right? All right, let's try and get all the cases. Let's move this up a little bit. All right, so what else can there be? Well, what if the person does a rock, right? And now notice we don't have to deal with any of the ties. We don't have to do rock. All right, so what if person dot equals, remember we can't do equals, dot equals, let's see, string rock. So that's a quote R quote. Anything in double quotes is a string. And the computer plays, let's say, paper. We're not doing rock, right? We're doing rock, paper, and rock, scissors. That's all we're doing in this case, right? So let's say computer, the computer move dot equals. So this is just a boolean statement. Let's say paper. Now, what happens? Who wins? Paper covers rock, right? So computer wins. Okay. So let's write that. All right. So then what you do is temp equals computer wins. There you go. All right. Well, there's a third case of a person playing rock. We already did person playing rock, person playing rock, paper. How about person playing rock and it's rock, scissors? Whoops, what happened there? Okay. It keeps on losing the focus of the editor. There's the cursor. Okay, so if, let me copy this whole thing. So it's almost like this. Let's copy this. Let's put it here. Okay, so if a person plays rock, but computer plays scissors, then rock crushes scissors, so person wins. Aha. Perfect. All right, so that takes care of all the R's and all the ties. Now we have to do 2 more cases for a person playing paper and 2 more cases for person playing scissors, right? Okay, so let's do that. What if I copy these 2 cases? Remember, we took care of paper already. Let's do paper. So if person plays paper, and we don't have to worry about paper, and we have paper, scissors here. How about paper, rock? All right, so who wins? Paper covers rock, right? So person wins. Paper covers rock, person wins. Right, okay, so let's write that down. Get over here. So person wins. Okay, and what if person plays paper and computer plays scissors? Scissors cuts rock, so computer wins. Good. Nice. Okay, let's move this up a little bit. All right, that's almost it. I guess 2 more cases, right? Because we took all 3 ties, we did all 3 rocks, all 3 papers. We got to do 2 more to get all 3 scissors, as if person plays scissors. So how about if I put it here? Whoops, it keeps on doing that. All right, so now what we're going to do is going to do person playing scissors. All right. And what we find is that we don't have to worry about scissors. So we got scissors, paper. How about scissors, rock? Okay, so if person plays scissors and computer plays paper, scissors cuts paper, person wins. Yep. And we can add like a scoring system to this once we get loops and stuff going on. But let's do that next time. Maybe C5X0. All right. So if person plays scissors and computer plays rock, rock crushes scissors, so computer wins. Okay. I think that's all 9 cases. 9 ways to tie. 9 ways that people can play rock, including the tie. 9 ways that a person can play paper, including the tie, and 3 ways for the person to play scissors, including the tie. I think we got everything. So this is computer. And that's the whole thing. Now you could have done this with a get winner accessor, but why? Alrighty, and let's save. And also note that if you put in here, if you put foo.toString, it's the same thing. So in other words, the printline method knows to automatically call this toString method for an object if it's printlining an object. So I used it before without the foo.toString, and now just foo, and now foo.toString is going to do the same thing, but it's got all cases now. So I mean, you don't have to do that. I'm just showing that it's the same thing. You probably don't want to do that, and the point is to just print foo is nice. All right, but let's see. What did we mess up? Nothing. Java C is happy, so syntax is good. Java, let's see if Java is happy. In other words, it's semantically correct. Okay, rock. Okay, so computer wins. Let's do another rock and see if we can get person to win or a tie. Computer wins again. Hey, is that right? Computer is paper, covers rock. Right, okay. Yeah, okay. Same, it was the same move. Okay. Okay, there's the tie. Now, let's say rock, scissors. Can we get rock, scissors to work? Make sure that's working. Not yet. No, it's not the person can't win. You can only tie. Person wins. There it goes. Okay, nice. All right, let's run it again. Now I did that for rock, for person playing rock. All 3 cases for person playing rock. It's a person win, a computer win, or a tie, right? Okay, let's do, just for fun, let's do all 9 cases. So the 3 cases for paper. We're checking that's semantically correct. All right, computer wins if it's scissor over paper, right? Okay, run it again. For human move is paper. And now person wins because paper covers rock. Perfect. Okay, now all we need to see is a PP, a tie with paper. So do we get a tie? Nope. 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 There it is. Okay, so we got all 3 cases for rock, for when person plays rock, all 3 cases when person plays paper. Let's see that all 3 cases when person plays scissors working okay. We're checking the Java time, runtime, late binding time is semantic, right? We're checking the semantics of our program. All right, so we're inputting scissors for the human move. Okay, the computer wins. Let's see if we can get person to win or a tie. with an input of scissors. Good. And let's get person to win with scissors inputted for person. Perfect. Nice. One other little thing. What if your user, remember, you got to be user friendly. You got to catch possible errors. What if your user does this? And that's a problem. That should be a tie. So how do we get the let's say the tester to ignore the case? All right, let's go back to the tester. It's testing for lowercase r, p, and s, right? In other words, the computer moves are all lowercase, and then over here we're testing that everything's all lowercase for person and computer moves, right? So how about we make sure that the input is always lowercase? How about we go over here, and whoops, where's my cursor? I lost my cursor again. Okay, what if we take this string, and input.next is a string, right? Let's make sure we know what we're talking about. Yes, input.next is a string, and there's a string method called toLowerCase. So how about we just make sure it's a lowercase no matter what the user inputs. There you go, toLowerCase method. All right, save that. Let's see if that works. So clear. Java C, RPS tester. Let's see if we messed up. Nothing. And then get rid of that Java. And get rid of the C in Java C. And if I do lowercase r, everything's happy. If I run it again, and uppercase R, and person wins. Rock, crush, scissors. Yeah, that's it, done. All right, that's it. So hope you learned a lot about if statements and toString methods, and even the dot equals method. So the dot equals method is a boolean. It compares the private instance fields of two objects and make sure that they're the same. If it returns true, then otherwise it returns false. The toString method returns a string that describes your object. And there's a default equals method we inherit from the object class, and a default equals toString method that we inherit from the object class, which we really usually have to override, in other words, rewrite it for our class. So there's your tester. There's the input for the user. There's the move for the computer. And there's the constructor for the RPS object and printing out stuff about RPS. Okay, and here's RPS. So what do we have here? We have two private instance fields for the person move and the computer move, and just setting that up in the constructor. And then your basic accessors, and then like this massive accessor that does a lot of stuff. This is like a massive accessor. It really describes the object, okay? In this case, I wanted to see who won, so there you go. So it's going to print out who won. So there's all three cases for a tie, two remaining cases for person playing rock, two remaining cases for person playing paper, two remaining cases for person playing scissors, and then don't forget to return the temp, the temporary string variable. And that's it. All right, bye-bye, YouTube. Hope that was helpful.